In case you are just joining us for the first time, welcome to the Triune Physics, aka PhysicsBible. Today we'll be treating laws of refraction. This is under refraction of light rays. Note that we've already treated this topic using biblical concepts. Do check our channel for that, or click on the link as displayed on your screen. But for today, we'll basically focus on physics and the triune components of the laws of refraction. Welcome once again. There are two laws of refraction. There are two laws of refraction. And we're going to draw a diagram to represent that. So let's begin by tracing out the outline of a rectangular glass prism or glass block. This is the outline. If you are given a glass prism, you trace it. That's your first step. So we are using this diagram to represent that. Then you draw your normal. Your normal, which is N1, has to be drawn on the first interface. Okay? So let's draw our normal, which indicates N1. Then our incident ray will be represented. Yes, this is our incident ray. Okay? The source of the light. Then at the other end, we have the emergent ray. Of course, you are going to introduce your normal too. So the ray you are seeing is the emergent ray. It is coming out from the glass prism. Then the light will be refracted within the glass prism. So if you look at the rectangular shape, you are going to have a refracted ray. The ray of light is going to bend. Yes, you can see it bending. So having a contact with the incident ray and the emergent ray. I hope you are following. Let's label our angles. The first is the incident angle situated at the first interface. It is called I. Okay? Then we have the angle of refraction. They are both equal to each other. Then we have the emergent angle, E. I hope you are following. Then we are going to represent or label the rays. We have the refracted ray in green. Okay? We'll label that as the refracted ray. Are you here? Refracted ray. Then we have the emergent ray, which is the E. The E is the emergent angle. The line is the emergent ray because that is the source of the light. Then we have the incident ray, which denotes the line. Okay? Then the angle is I. Please take note of the differences. Are you here? Then the ray of light travels towards the same direction, even though it bends or refracted. It still travels from air through glass back to air. I hope you are following. Yes, that is that for this. Now let's capture the laws of refraction properly. Number one, the law states that the incident ray, okay, the refracted ray, okay, and the normal at the point of incidence. At the point of incidence, are you following? All lies on the same plane. All lies on the same plane. Take note of this. Now, let's highlight this law. The incident ray, that is the line. Okay? Let's circle it. That's the incident ray. That's number one. Triune components of the first interface. Then the second is the refracted ray. You can see it is having contact with that interface. Okay? And the normal. You can see normal. Let's write that. normal. You can see that line that is perpendicular to the surface or interface of the glass prism at the edge. That's our normal. These three all lies on the same plane at the point of incidence. Where's the point? The center. You can see it there. Let's circle it. They all lie on the same plane. Are you following now? Don't forget, all lie on the same plane. The same plane, circled. So, what are the triune media? The first is the air. Okay? The second, glass. The third, air. I hope you are following. From air through glass to air. Then the second law now, the ratio, understand the word ratio means division. The ratio of the sine of the angle of incidence. Okay? The angle of incidence to the angle or to the sine of the angle of refraction. Please, refraction, not reflection. Refraction is a constant. That means it doesn't change. That means it is fixed. The value is known for a given pair of media. That is two medium. The plural of medium is media. Okay, let's say air and glass. So the value for the refractive index is constant. I hope you are following. So the word ratio, let's circle it. The ratio means division sign. So let's capture that. We want to write this mathematically, please, so that you can use it to solve mathematical problems in physics. So the ratio, division sign, captured, of the sine of the angle of incidence. Of the sine of the angle of incidence. So we're going to capture that too. Are you with me? So ratio captured. Sine of the angle of incidence. It means sine I. Okay, sine of the angle of incidence. Sine I. Look at it here. You can see where I is. Let's circle it for you. Look at it there. Sine I, please. That's the angle. Okay. To the sine of the angle. To the sine of the angle of refraction. Okay, look at the angle of refraction. Look at them. They are equal to each other, please. Take note. So that's the angle that this law is referring to. R, you can see it in between the normal and the refracted ray. So sine R now. Okay? So sine I divided by sine R is equal to constant. That's what it means. Is equal to constant. So let's write that is equal to constant. And this constant, the symbol is this. Okay, we can use N or you can use the Greek alphabet to represent that. And this constant is for a given pair of media. It can be air and glass, or it can be glass and air. Take note of that. Hence, this second law has another name. So the second law of refraction is also called Snell's law. Okay? Snell's law. Please take note of this. If you are asked to state Snell's law, this is what you are going to write. And you express it mathematically. Are you following? Hence, our constant is also called the refractive index. So where our constant N, where our constant is equal to N and is equal to refractive index. Please take note of this. Refractive index of the second medium. So it has to be the glass. Okay? Second medium If you have any question, drop them in the comment section so we can go through them. So, refractive index of the second medium. Take note of this. Now, recall that it has to be one medium to another. So, there is no medium that will act in isolation. Refraction depends on two medium. It has to be either air and glass, or glass and air, or even air and water, or glass and water. So if light is traveling from, let's say, air, okay, it travels from air to glass, then what will be your refractive index? Let's look at it. This air to glass. Now, this ray of light will penetrate through the glass prism. Now then it will now bend. So the refractive index, which is N, the refractive index is given to be, let's write that. Of course, you know the default formula or equation to be A to glass, which is air to glass, is equal to sine I in air, all divided by sine R in glass. Are you following? So the A to G means from air to glass, the refractive index. So what about if light, that's the second one now. This is the first, we have three of them, the triune explanation. If light travels from glass to air, you see, this is the reverse of the first. So what will be your formula? The refractive index will be given to be, we have, is given to be, or is given by, let's write that now, glass to air. So glass to air. Let's capture that now. So that your refractive index from glass to air, which gives you GNA, okay? G to A is equal to sine I in glass all over sine R in air. Are you following? So if that's the case, this gives us a refractive index at the second instance. So from the principle of reversibility, of light, that light can be able to take its source, the original source, even though it has been refracted. If the whole scenario is reversed, then we'll now have A to G, that's refractive index of A to G, okay, will be equal to 1 all over the refractive index of G to A. Are you following? So this gives us the principle of reversibility of light. You are inverting. So this is our formula. Please take note. You can apply this to get your answer if the question comes in this format. So what are the triune effects? The triune effects of refraction. When refraction takes place, what happens really to speed and the rest? Number one, there is a change in speed. Your V will change, the value will change. Then number two, we have the change in direction. You can see that practically from air to glass. Then number three, there is a change in the wavelength, which is lambda. There's a change in the distance. Are you following? So these, we term them to be the triune effects of refraction. And each of these has its own formula, okay, following the same process. Now, if we capture speed, when light travels when light travels from air to glass. Okay, if we are considering the speed of light, then A to G, that's the refractive index, will be the velocity or the speed of light, in air, or divided by the speed of light in glass, which will also result to, which is equal to V of A all over V of G. Are you following? So this is another formula for refractive index. Join us in the next episode. Connect to our social media handles at PhysicsBible, the Triune Physics, for latest update. Thanks for joining us. Stay equipped, stay liquid.